Welcome to Train Signal. You're watching a video about the OSI model. In this video, we're going to start off by reviewing the definition of a protocol. Now, we talked about what a protocol is in a previous video, but I'm going to lay it out for you in a little more detail here in this video. And the reason why is because I'm going to show you how this all associates to something called the OSI model. And after we see what the OSI model is and how it works, we will take a look at the different layers of this OSI model. Now, before we get into that OSI model, let's go back a moment and talk about what is a protocol. Well, a protocol is a set of rules and procedures used for communication. And the way I really like to lay this out for you is by using an analogy of using other forms of communication that are outside of computer networking. So for the sake of argument here, we're going to say that we want to send a letter to a friend. Now, in order to send that letter to a friend, we have to decide on a company to use to ship that letter, to send that letter. Now, in this case, we're going to go ahead and say we're going to use the United States Postal Service. Now, with the United States Postal Service, they have their own protocol, their own set of rules and procedures for communication. And the first rule they have is that you have to take that letter and put it in an envelope. So here on the screen we have an envelope. Now, once we've put the letter in the envelope, then we have to put a destination address on that envelope. And there's something I need to tell you about this destination address. The address itself, or I should say the addressing itself, is kind of its own little sub-protocol. In other words, you can't just put this address anywhere on the envelope, and you can't just write it, any random set of numbers and letters and words that you want. You have to have it in a specific location, front and center on the envelope, and you have to have everything formatted in a certain order. Right? You have to have your name on top, followed by the street number and the name and the suffix, etc., etc. So actually, we could refer to this United States Postal Service protocol as a protocol stack or protocol suite. And later on, we'll see how in computer networking we have the same thing going on. Now, what do we mean by a protocol stack or suite is that we have a bunch of smaller protocols or sub-protocols that are all working together to make up this larger protocol stack. Alright, so now that we have the destination address, the next thing we need to do is to put a source address. Or, as we call it in the United States Postal Service, a return address, right? And again, that return address has to be in a specific location. As a matter of fact, there's actually two locations it could be, but it still has to be formatted a certain way, so that's kind of its own little sub-protocol. And then after we have all the addressing done, right, the destination and the source, well, we have to pay the United States Postal Service to send this for us, and we do so by affixing a stamp of a certain value based upon the weight and size of this package in a specific location on the envelope. Now, after we have the letter put in the envelope, and we have all the addressing put on the envelope, and we have the stamp put on the envelope, we have to figure out how to get this package onto the United States Postal Service network. So what do? We stick it in a mailbox. Now, if you follow all these rules and procedures as they've been laid out by the United States Postal Service, well, then guess what? Your letter will get to your friend. But the United States Postal Service is not the only way to send a letter, right? Let's say we wanted to send it via FedEx. Well, here I have a picture of a typical FedEx US Air bill, and you'll notice that it's kind of different than just what we wrote on the envelope, right? I mean, we have to go ahead and, I know it might be kind of hard to see here, but here we have an area where we can put the source address where it's coming from, and here we have an area for the destination address where it's going to, and then over here we have payment, right? So how are we going to pay it? And what I don't have pictured on this screen is the different type of envelope that's used, right? There's a special FedEx letter envelope. And then also, what about getting it out onto the FedEx network? Well, there again, you can't just put it in a regular United States Postal Service mailbox. I mean, you might get lucky. The postal carrier might go ahead and take it out of the box and stick it in the FedEx mailbox for you, or some other means. But point being, you have to find a way to get it out onto the FedEx network. But once again, if you follow all the rules and procedures as they've been laid out by FedEx, well, then your letter gets to your friend. But now here's a question for you. What if we wanted to go ahead and send that letter via FedEx, but we want to send it to a United States Postal Service P.O. box? Well, that can't happen. Okay, and the reason that can't happen, and I know it's really small in this picture, but there's a spot on here where it requires a signature. Okay, and you can't get a signature when you're dropping off in a P.O. box. So what that means is, in order for communication to take place appropriately on any network, you have to agree upon a common set of rules and procedures. And so again, computers on a network must agree upon a common protocol in order to communicate. Now, I will tell you that the reality is, by the way, and just a little side note here, you can send a FedEx letter to a US P.O. box. But this can only be done if the US P.O. box is at a location that has a physical mailing address, a street address, and has a human there to sign for the package to put it in the box. Now, there's a number of these different little places out there. I know one place used to be called Mailboxes, etc. I believe they got bought up by UPS, actually. But anyway, the point is that there are certain locations where they'll have US P.O. boxes, and that location has a physical street address, and there's a human there to actually sign for the package and then put it in the post office box. Now, that human, we refer to that human in computing terms, in computer networking terms, as a gateway. Now, I don't want you to go too far with this yet, because we really haven't gotten into all these details. But I just want you to have this in the back of your mind for when we get there. First of all, there is a difference between a default gateway, if you've ever heard of that, and a gateway. The gateway that I'm referring to in computer networking is something called a protocol translator. And that's what the human is at that location with the P.O. box. That person signs for the FedEx package and therefore pretty much completes that process and then puts it in the post office box so as to be able to complete the process on that end. So it's a translator of the two protocols. Anyway, enough of that. Don't worry about that if that confused you. I just wanted you to have that in the back of your mind because we will talk about that later on. Now, what the heck does this all have to do with the OSI model? Well, you may have realized as I was going through that demonstration that regardless of what carrier you decide to use, we had to have packaging, right? Didn't matter, United States Postal Service or FedEx had to put the letter in some kind of an envelope or in a package. And again, it didn't matter, FedEx or United States Postal Service, you had to address the package, right? You had to put both the source and destination address on it. Again, didn't matter which one you wanted to use, you had to pay for it. And whichever one you want to use, well, you're going to have to get the package out onto their network somehow. And as a matter of fact, there are many different carriers that go way beyond the United States Postal Service or FedEx. And with each and every one of them, if you want to send a letter to a friend, well, it's going to have to be packaged, addressed. You're going to have to pay for whoever service is going to do it. And you're going to have to know how to get it out onto their network. Okay, so it really doesn't matter which one you use. You have to follow all of those basic high-level rules. And that is exactly what the OSI model is. The OSI model, matter of fact, let me go ahead and read this to you here. Back in the 1970s, the International Standards Organization, or ISO, developed the Open Systems Interconnection, OSI, reference model to define the basic standards for network communication. Okay, I mean, there's really no better way to put it other than to put an emphasis on that last line there, to define the basic standards for network communication. That's what the OSI model is. It's what sets up the rules that all computers have to use, no matter what protocol they're using. No matter what, all computers are going to have to follow, as a for instance, to the analogy, the rules that say there must be packaging, there must be addressing, there must be payment, and you must know how to get it on the network. So now that you know what the OSI model is, let's take a closer look at it. Well, first thing you need to know about the OSI model is that it is made up of 7 layers. Okay, and I have them listed for you right here. We have the application, presentation, session, transport, network, data link, and physical layers. And I will tell you that the very first thing that you're going to want to know about the OSI model is just those 7 names. Sometimes that can be a trick in itself, just remembering those 7 names. So, what we want to do is go ahead and just take a look at the first letters, right? The A, P, S, T, N, D, and P. And then what a lot of people tend to do is they will go ahead and come up with some kind of catchy mnemonic saying like, all people seem to need data processing, that maybe is easy for them to remember. And then with just a little bit of studying, that saying that starts with all the same letters will then lead you to remembering what the actual true names of the layers are. Now I will tell you, all people seem to need data processing has been around since, well, almost since forever. It's been around a very long time. But a lot of people say, well, that's not really any easier for me to remember. So another catchy one that I've heard out there is if you go from the bottom up, instead of going from the top down, if you go from the bottom up, we have please do not throw sausage pizza away. Well, again, maybe that's catchy for you, maybe it's not. It really doesn't matter. You can come up with any saying that you can imagine with these 7 layers, or I should say these 7 letters, to help you remember the 7 layers of the OSI model. Matter of fact, here's some additional ones I found out on the internet. We have a priest saw 2 nuns doing push-ups. That one's just kind of an interesting vision in itself. All people should try new Diet Pepsi. Please do not take salespeople's advice. And please do not tease stupid party animals. I'm not sure where people come up with these things, and I can tell you that I could have put pages and pages of sayings up here for you. There's so many of them out there, but just find one that is catchy for you. And then, like I said, once you remember the first letter, with just a little bit of studying, you will go ahead and remember the actual 7 layers. Now, what the heck is this mess I've just put up on the screen? Well, what I have on the screen for you right now is what I like to call my 1-page cheat sheet to everything you will need to know about the OSI model. And it's not necessarily everything you need to know about the OSI model for the rest of your life, but everything you should need to know as somebody who's trying to get into computer networking. This should answer just about everything that you would need to know for the Network Plus exam if you're planning on taking that. And it should help you out with pretty much anything you would need to know about the OSI model, maybe for a job interview, or just in general, understanding a little bit more about what the OSI model is. Now, I will tell you, when you get a little deeper into this, there are all kinds of instructional guides that you can find out there about the OSI model. And as a matter of fact, I can remember, I actually was recently looking for it. I can't find it, but I have an 11 by 17 sheet of paper, so 11 inches by 17 inches, that is jam-packed from end to end, top, bottom, left, right, all the way around, with diagrams and explanations all written in 6-point font. You almost need a magnifying glass to read it. And there's almost no dead white space on that paper. That's how much detail there really is into this OSI model. But I don't want you to worry about all that. I want you to keep this really simple right now. Just what I have on the screen is all you should need to know. Now, I know you're probably looking at this saying, wait a minute, Ed, that's fine, but what's on the screen right now is pretty busy and kind of looks a little intimidating to begin with. So let's break this down piece by piece and then you'll see that what's on the screen is really not that big a deal at all. Now the first thing that I want you to make note of here is just the 7 layers, right? Just application, presentation, session, transport, network, data link, and physical. One thing I should also mention before we go any further, just in case, this is almost more for test questions than anything else, but also could come in handy when you're learning about some of the hardware, is these particular layers are actually numbered from the bottom up. So the physical layer is known as layer number 1, data link layer is number 2, all the way up until the application layer is actually known as number 7. Okay, let me clear that off of there because that's not really what we want to look at right now. But just in case you get a question that comes in and talks about layer 2 or layer 3, you won't be thinking about the presentation or session layers up top. You'll be thinking about the data link or network layer down low. What I do want you to really focus on right now, though, is what takes place at each of the 7 layers of the OSI model. Now, before I go into this definition, or the definition of each of these layers, I want you to understand that this can be really difficult for a lot of people because there's nothing overly tangible about this. So for instance, if you open up a computer, if you take the cover off and you look inside, you're not going to find 7 chips that mirror to these 7 layers. If you look on a network card, you're not going to find 7 circuits that match these 7 layers. No matter where you look, you're not going to find anything physical to associate with all 7 layers. There's a lot of concept in this, and I will also tell you there's a lot of gray area in this. And if you read through different books, you will see slightly different definitions for each layer. So I don't want you to get too worked up about this. I want you to kind of just let yourself relax and take in just the absolute basics here. So that said, let's go right to the top here. Application layer. What takes place at the application layer? Well, network APIs are what the application layer is responsible for. And API, if you've never heard of that acronym before, it stands for Application Programming Interface. And it is just that. It's a programming interface between the computer and the network. It's how things programmatically get out onto the network. Or sometimes it could be said that this layer is responsible for just announcing to the network, hey, there's something coming out onto the network. There's something I need to send out onto this network. Okay, so again, don't get overly worried about exactly every little detail about what it is. It's just that application interface with the computer and the network. Now if we go down a layer, we get to the presentation layer where we have formatting. This is where we determine the format of the data. And I really need to emphasize the format of the data because you might hear the word format come up again as we go down through these layers because there's kind of a bit of formatting of some kind that kind of takes place at all layers. But this is the formatting of the data that's being sent. Okay, so that's what takes place at the presentation layer. Going down from there, we have the session layer, and this is where synchronization takes place. Now, let me actually go back a page here real quick, just bring all this clutter back on the screen, because I just want to point out to you that as part of this entire sheet that I have in front of you here, there's these 2 computers, right? We have our sending and our receiving computer. Right now, don't worry about which one's sending and which one's receiving. It's just understand there are 2 computers that are communicating with each other right now. Well, the session layer is where we go ahead and synchronize communication between those 2 computers. It's how they make sure that they're keeping up with each other, that no data has been lost along the way, that they're still in sync. Now, if we go down from there, the transport layer is where, well, the word I have there right now is packets. And sometimes when I draw this up, I'll put 2 words there. I'll put packet management. Okay, and in order to understand this, you have to know what a packet is. Well, when you have data that you want to send out onto a network, that data is typically not sent all together as one big piece. It's broken down into little chunks that the network can handle. and each of those chunks of data is called a packet. And so basically you could have, let's say, a document that you want to send from one computer, so we'll say computer A to computer B. Well, that document might get broken apart into 10 pieces or 10 packets, and it's the transport layer that will then manage each of those 10 packets and make sure that they all get from computer A to computer B. All right, going down a layer from there, we have the network layer, and this is where addressing and routing take place. Right? You remember in the analogy with sending a letter when we had to address the packages, right? Well, guess what? In computer networking, we also have to address the package. And so this addressing takes place at the network layer, but routing also takes place at the network layer, and we will see where that makes sense when we look at some of the hardware and how it associates with the OSI model. Basically, all of your IP type stuff, all your IP addressing and routing takes place at the network layer. And going down a layer from there, we have the data link layer, which is responsible for data frames. Again, sometimes I'll write this as data frame management. And this is where sometimes it gets a little confusing when you read it in a book, because I've read books that explain that the transport layer is responsible for managing packets and that the data link layer is responsible for managing data frames. And then on another page in the book, you will see the definition of a packet as being a synonym to the term data frame. Huh? I mean, if a packet and a data frame are the same thing, well, then how are they being managed at two different layers? Well, the transport layer manages the packets of data themselves, whereas the data link layer and the data frame management is really the packaging of the data, if you want to call it that. The best analogy I can give you, or the closest thing I can give you to our analogy, would be it's like putting the letter in the envelope. The data frame is the envelope. It's getting the data into a format, again, don't get confused with formatting up above, but into a format that is ready to go out onto the specific network. Okay, so that's what takes place at the data link layer. And then finally, all the way down here at the bottom, we have the physical layer, and all I have written next to physical is hardware. And that's because the physical layer is responsible for figuring out how the computer is connected to the network, right? It has to do with a cable being plugged into the network card, okay? So that's what takes place at the physical layer. So that is just a little bit about what takes place at each of the 7 layers of the OSI model. And again, I will tell you, there's gray area, there's overlap. One thing I can tell you about the data link layer is, well, there's a few things I can tell you about the data link layer. One thing is, and again, I don't want to overly confuse this right now, but the data link layer, just in case you ever see this, I will tell you that the data link layer is actually subdivided into 2 sublayers, one known as logical link control, or LLC, and one known as media access control, or MAC. And the term MAC, media access control, is something that, again, we're going to see a lot of going forward. If you've ever heard of a MAC address and management based upon MAC addresses, well, yes, that takes place at the data link layer. Another thing that takes place at the data link layer is something called error checking. And a lot of people get confused with that because you'll read in a book that error checking takes place at the transport layer, it takes place at the session layer. There's a lot of overlap here. Okay, so just forget all that. You know, now that I've thrown it out there so you can be confused, forget it all. All I want you to be familiar with are pretty much these basic terms that I have next to each layer. Application layer, interface between the computer and the network. Presentation layer, formats the data. Session layer, synchronization between computers. Transport layer, managing of the individual packets. Network layer, addressing and routing. Data link layer, put it in an envelope. Data frames. Physical layer, the hardware. How's the cable connected to the network card? That's it. Now, once you are familiar with what takes place at each of the 7 layers, we need to draw a little bit more. Okay, so I haven't brought everything back yet, but I drew out a bunch more. And what I did was I made it that there's now 2 OSI models. Again, we have our computers at the top, and now it is significant that the sending computer is over here on the left and the receiving computer is over here on the right. The other thing I want you to notice is these little arrows. You'll notice that on the left side here, the arrows are pointing down, whereas on the right side, the arrows are pointing up. And the reason why is because this is how data travels through the OSI model. Again, really confusing to a lot of people because there's nothing physical that it's traveling through. It's logically how it travels through the OSI model. It's significant that I've put the computers up at the top, up above the OSI model, because down here at the bottom, I don't know if you noticed this, but I've also drawn a network cable connecting the 2 physical layers, right? Isn't that what we said the physical layer does? That connects the cable to the computer. And the reason this is all significant is because when the sending computer has data to send to the receiving computer, that data is sent down through the OSI model until it can get down here to the network cable. Okay, so the computer sends it to the application layer, who does its thing, sends it down to the presentation layer, who does its thing, which then passes it down to the session layer, who does its thing, etc., all the way down till you get to the physical layer, who says, all right, here's how we're connected to the network. The data then travels across the network to the receiving computer, where again there's a cable connected to the physical layer, and then data must be passed up through the OSI model in order to get to the receiving computer. Now again, this is conceptual, this is logical, but it's real. Okay, so that's why I drew this picture for you. Now, even though data travels down and up, and even though each layer passes the data to the next corresponding layer down or up above it in the OSI model, well, what are these dashed lines that I have going between each of the layers? Well, these dashed lines represent the virtual communication that takes place. And what I mean by that is, even though the application layer is doing its thing and then sending it down to the presentation layer, and then the presentation layer does its thing and sends it down to the session layer, and the session layer does its thing down to the transport layer, etc., all the way down, well, when it goes across the network and gets to the other computer, what happens is the physical layer only acknowledges what the sending physical layer did to the data, and then passes it up to the data link layer, who then acknowledges what the source data link layer did, and then sends it up. And that process keeps happening all the way until you get back up to the destination computer, who then just has raw data that was originally sent. Now, all these crazy lines are probably confusing the matter, so I'll tell you what. Let's use a little better illustration so that you can really see how this works. The way this works is you have a sending computer that has some data, and that data needs to be sent, as I mentioned, down through the OSI model. And as it goes down, each layer adds its own piece of information to the data. Now, I don't know if you caught that there, but each layer basically added a slice over to this side of the data, or what's commonly referred to as header information to the data. Okay, so we can say each slice of information. Whereas the data link layer also added this slice as well, which is what's known as a trailer, and it's that trailer piece that is used for error checking. Okay, and again, there is error checking that takes place through many of the layers of the OSI model, but it's kind of like making sure that the envelope wasn't damaged or the package wasn't damaged in transit. So, after the data has gone all the way down through the OSI model, and now we have data and all this extra header and trailer information on it, it gets sent across the network to the other computer, where the physical layer and each corresponding layer on the way up strips off and acknowledges its piece of information that matches from the equivalent layer on the sending computer, until we end up back up here at the destination computer or receiving computer with the original raw data that was meant for it. Okay, so that's how data travels through the OSI model. It goes down, each layer adds something, it goes across, and each layer then removes something, so that as far as the computers are concerned, I'm just sending raw data and I'm receiving raw data, and all is well. Alright, so now we understand this much of my one-page cheat sheet, but we have one more piece to go. And that's over here on the left. Over here on the left, I have written in a few different pieces of hardware, of networking hardware. Now, these are not the only networking devices that are out there, but these are some of your most common devices, and the layer that I've written them in next to is the layer in which they have functionality. So as a for instance over here, we have a hub or a repeater. Now a hub, which is really nothing more than a multi-port repeater, so a hub or a repeater is a device that has no intelligence whatsoever. All it does is basically have a cable connected to it, and anything it hears, it turns around and repeats back out again. And so therefore it works at the physical layer because it just has to deal with how the cable's connected, right? You got the cable coming in, you got data coming in, we're not going to do anything to that data, we're just going to send it back out again. Now if we go up a layer, our layer 2 devices, as they're sometimes referred to, would be a bridge or a switch. Now, one thing I really want to emphasize here is the switch. And that is because nowadays there are many different types of switches out there. You may have even heard of a layer 2 switch or a layer 3 switch, which means obviously that is a switch that is working up here at the network layer. But for right now, we're going to go back kind of old school, older technology, where a switch was just like a multi-port bridge. Now a bridge or a switch is a device that can do routing, but not sophisticated like a router can. It does routing based upon the MAC address of a network card. And again, remember, the data link layer is divided into a couple of sublayers, which include the MAC or media access control sublayer. So that's why a bridge or a switch functions at the data link layer, because it does routing based upon that MAC address. Going up a layer, we have our routers. Well, this makes absolute sense. This is probably the one thing that confuses nobody. When I put my one-page cheat sheet up on the board in a class, very often I'll have people look at it and say, I only get one piece, and that's the router. Because I see router, I see the word network, I see that the network layer is addressing and routing. It all makes sense. And you know what? There's not much more to be said. Routing takes place at the network layer, and so therefore a router functions at the network layer. Now the last one that I have here is way up here. I have the gateway written all the way up at the application layer. Now remember, a gateway, not a default gateway, which by the way we'll get into this later, but in case you're wondering, a default gateway is another way of referring to a router, actually. So that's not what we're talking about here. We're talking about the protocol translator version of a gateway. In other words, when we have two computers that need to communicate using different protocols, as long as there's a gateway involved that can translate those protocols, we can have communication. Well, gateways can actually have functionality at any layer of the OSI model. But typically, a gateway tends to, most of your typical gateways will have their protocol translation being done either at the application layer or somewhere in the upper area of the OSI model. So just keep in mind, typically gateways function at a high layer in the OSI model. And that right there, well, that's your one-page cheat sheet to everything you should need to know at this point about the OSI model. Alright, well that pretty much wraps things up for this video. And at this point, you should now be able to thoroughly explain what a protocol is and how we use it to allow computers to communicate on a network. And you should also be able to define the 7 layers of the OSI model and explain not only the OSI model's significance within a network, but each of the layers' significance within network communication. And I will add to this, you should also now know how data travels through the OSI model. And one little added note, remember the left side there, we looked at some of the hardware and where it communicates with the OSI model. Alright, well that's it for this video. I'll see you in the next one.